Here we are to the GOAT's ultimate practice test, and we finally have a calculator section. The worst and most annoying part about the calculator section of any AP exam is you probably don't need a calculator for most of them. For example, this one, you don't need a calculator for. So I'm not going to pull out the calculator. Why do they pull it on the calculator section? I have no idea. I'm not the Lord of AP. But a turtle is walking away from her home at a constant pace for 5 minutes. The turtle then stops for a short time to rest. After resting, the turtle spots food and moves at a rate 2 times faster than before, reaching her destination at 10 minutes. So without looking at this, you have a turtle walking slowly. At 5 minutes, it stops. And then it doesn't give us a specific time, but what it says, it goes 2 times faster. So you're going to try to make a line that's 2 times steeper, and then all of a sudden you hit 10. So which one of these has a regular line going to 5, stops for a little bit of time, and then has a double looking steepness line, and then stops at 10? You look like you are going to 5, stops, but this line is the same as that line. That slope is the same as that slope, or at least it looks like it. Like if I were to take that line right there and compare it, yeah, they're the same. So you are not it close, but you are not it. You are going at a regular pace, stops, and that looks like it's double. That looks like it's double. I mean, you go from 0 to 5 in like 5 minutes. So, like 1 foot per second, 1 mile per hour, whatever it is. Okay, then all of a sudden you go from like 7 to 11 or whatever pretty quickly. So you have promise. So I'm going to hold on to you for a second. C has me going really fast, stopping at 5, and then slowing down because this slope is obviously not as steep as that slope. And then D kind of looks like the same thing, but I'm just going to ignore D because D has me saying that I stop at like 3 minutes or whatever, and this has me stopping at 5 minutes. So D's no good. So yeah, B is the correct answer for this guy. Again, where was the calculator for this problem? Nowhere. Nowhere to be seen. But, that's the way these AP tests go sometimes. They say you should use a calculator or can use a calculator, but you don't need to use the calculator. So hope this helps. In a certain simulation, the population of a virus-infected cells colony, sounds like fun, can be modeled using a geometric sequence, where the first day of the simulation is day 1. That's usually the case. The population on day 4 was 8,000, all right, and the population on day 8 was 72,000 virus-infected cells. What was the population of the colony on day 6 based on the simulation? Well, we have ourselves a calculator problem, and if you're wondering, how can I do this problem? There's no geometric sequence thing on my calculator. You're right, there isn't, but there's a little guy called expreg. And if you're like, what's that? That's called exponential regression. And what exponential regression does is gives you an exponential function. And if you're thinking, yeah, okay, great, but it says geometric sequence. Buddy, a geometric sequence is an exponential function. They're the same thing. It's just usually a geometric sequence deals with like a term 1, term 2, term 3. And with exponential regression, you're allowed to use like zeros and stuff like that, negatives. Where that wouldn't really make sense with a geometric sequence. They're still the same thing. So what we're going to do is we're going to run to our calculator. We're going to plug everything in. We're going to actually plug in 1 8,000 and 8 72,000, hit exponential regression, get an equation, and then see what happens when we plug in 6. Let's do it. All right, so if we're going to do any type of regression, exponential, linear, whatever, the first thing you're going to do is you're going to hit stat and then hit edit. Okay, so the 2 points that I had were 4 8,000 and 8 72,000. So 4 and 8 are going into my L1, my list 1, and 4 matched up with 8,000, so let's type that in, and 8 matched up with 72,000, so let's type that in. Let's go back to stat. Let's go back to calc. And what we want is exponential regression, which is way down here at 0. exponential regression. You're going to hit enter a bunch of times. Now, here's the thing. I'm going to use this equation to answer a future equation. So what I want to do is I want to store this so that when I hit y equals, it's going to be there. So you go to store regression equation, go to vars, go to y vars, hit function, hit y sub 1, and what that means is that's the equation that I come up with is going to store it in y sub 1. So we hit calculate, lots of 8s, 1 point whatever. I don't want to have to write that out. I don't want to have to remember that. All I want to do is go to y equals and see that it's there already. So what do I need? I need day 6. So if I want to plug in 6, that's an option, but not a fun one. So now that I have that in y sub 1, why don't I go to second table and go down to 6 where it tells me that it's 24,000. So my answer for day 6 is 24,000. So let's go back and answer it. All right, so our guy was 24,000. 24,000. So yeah, that's how you do it, exponential regression. The key there and the easy part there is that store equation thing, the store reg EQ thing, and hitting vars, going right, enter, enter. That makes life a lot easier. So try to remember that. You're going to be happy you did. Hope this helps. The function f of x equals x cubed minus 19.7x squared plus 91.74x minus 78.408 has a domain on x's in between 0 and 15 and including. At what x value does the graph of f of x change from decreasing to increasing? So this is obviously a calculator problem. And what I'm going to deal with is not only typing that in and graphing that, but also changing my window so that I can see all the action happening between 0 and 15. A regular calculator shows you -10 to +10. I want to see 0 and 15. So let's run to our calculator and see what that looks like. All right, so let's go to y equals and type our guy in. X cubed is going to look like that. Then I have minus 19.7x squared, so minus 19.7x. Here's the squared button. Plus 91.74x, 91.74x. Minus 78.408, so minus 78.408. What I'm trying to do is find out where this guy is decreasing to increasing. Okay, now what that looks like, and I'll try to demonstrate that here, is you're going down and then hitting a bottom and going up. Now, as I said a couple seconds ago, when I hit graph, it's going to give me stuff happening from -10 to 10. Obviously, I don't see everything I want to see. I want to see from 0 to 15, which shows up way over there. So I'm hoping that this goes back up. It's got to, otherwise this problem's defective. So I'm going to go to Window, and I'm going to change my x values from, let's do -1 just to be on the safe side, to 16 just to be on the safe side. Now, when I hit graph, I know that my graph is going to be my picture is not going to be tall enough or it's not going to bottom out enough. See right there. So what I want to do is I want to change my window to change the y values too. So let's change the y min to -30 and change the y max to +30 and see if that does the job. Maybe it will, maybe it won't. Graph, no, it won't. So let's do it again. Now, if you're wondering, I know how to use these calculators. Why don't you hit zoom out? Because if I hit zoom out, that changes the x's, and I want to keep the x's the way it is. So let's do negative. No, not two negatives. That's impossible. How about negative? That looks like it went out a lot. So let's do -100. Maybe it's too much, but who really cares? What did I do? Oh, did I use the minus sign? I did. Negative. Learning lesson, kids, don't use the minus sign. Let's do 50. Not that we care about how high it goes. We care about how low it goes. Still not low enough. Man. So let's go to Window and do -200. Hit graph. There we are. All right. So again, what we care about is where it goes from decreasing to increasing. So what we need is to find that local minimum right there. Local minimum. Now, how do I find a minimum value? Go to second, calc. There you are, minimum. So you can hit 3 or you can scroll down and there it is. Now it gives you a little blinky thing and we want to put the left bound on the left side of our minimum. So it's already there, so let's hit enter. Let's move to the right side of our minimum. There we go, there we go, there we go. Hit enter. And what this is saying is that your minimum is going to exist between these two areas. Now, if for some reason we weren't thinking and we put our left bound way over here, we're not going to get the area that we want. We have to make sure we have our left bound just to the left of our minimum and our right bound just to the right of our minimum. For guess, you always hit enter. I've never seen a time where guess was, important. But what we get here is our minimum happens at 10.10801. So 10.108 will do it. So let's go back and circle the option that gives us that. 10.108, the answer is C. So the way this problem is worded again is they want to go from decreasing to increasing, which means they want a local minimum. Oh my gosh, which is right there. If they were to say increasing to decreasing, you would do the same idea, but find your maximum. So it's all in the wording. And as you saw in the calculator part that we just did, we had to change our window quite a bit until I felt happy about graphing stuff. So if that's what you have to do, that's what you have to do. Part of learning how to use these calculators is troubleshooting those moments when you're not satisfied the second or third or fourth time. You go to window and try to figure stuff out. So, weird problem. The problem in general is not weird. It's just having to throw it in your calculator. That's the weird part. So hope this helps. The table gives values for a function m at selected values of t. Which of the following graphs could represent these data in a semi-log plot where the vertical axis is logarithmically scaled? All right, so I don't need a calculator here because I'm just given 3 graphs. Now, I had to make this problem with just an A, B, and a C because it's very hard to create semi-log plots and fit them all on one slide, so I didn't do it that way. Now, what you're looking for is a semi-log plot A where the vertical axis is logarithmically scaled. That's thing number 1. A semi-log plot where the vertical axis is logarithmically scaled goes like this, and as you work your way up, things get a little bit tighter. Okay, I could have done a much better job showing that. But what we see in A is the vertical axis is just linearly scaled. It goes up 200, then 400, then 600. That's not the guy we want. This is just a regular old coordinate plane. Now, B and C, those are our guys where it's logarithmically scaled, where we go from 10 to 100 to 1,000 to 10 to the 4th. Same thing over here, even though it's cut off. And as you can see, the horizontal parts are kind of squeezing in, just like I said it would. Now, the table is given, and the table is not giving us linear values. The table is giving us values that are exploding. In fact, it looks like you multiply by a 4-ish number every time. Not 4, maybe like 3 point something every time to move your way up. Okay, so this is exponential. I don't know exactly what that number is, but it's exponential. Okay, when these guys go up by 1s, this goes up by a multiple every single time. Now, on a log plot, if you have an exponential function, it would appear to be linear. And C gives me that. One more time, on a semi-log plot, if you have exponential values, the dots appear to be linear, and C gives me that. B gives me what looks like is quadratic or something like that. It gives me a curve. If you have a curve on a semi-log plot, you don't have an exponential function. So it's not going to be B. So although the temptation is to look at this and be like, oh yeah, no, it's exponential, so it should look like that, exponential growth. Yeah, it'll look like this on a rectangular plane, but it'll look like this on a semi-log plot. So one of those things where you only see semi-log plots really in AP Precalculus. I've never seen it anywhere else in my 20 years of teaching and extra 6 years of colleges. So take it for what it's worth. Semi-log plots, super important. But, hope this helps. Let g of x equals 9.651 cosine pi over 5.543 x minus 1.269, nice, plus 1.911, nice, on intervals 0, 10. Which of the following statements is not true? All right, so we need the lie in all of this. We need the lie. So obviously what I need to do is I need to run to my calculator because there's no way I'm doing this without a calculator. I'm going to y equals, I'm plugging that in, I'm graphing that on 0, 10, which is good news. And, seeing which one of these is not true. So let's go and see what happens. All right, let's graph this really gross equation. We've got y equals 9.651. Here's my cosine. It automatically pops up a parentheses. I'm really paranoid with fractions, so I'm just going to put a parentheses there for the fraction. Probably not necessary, but I don't know. I'm afraid if I don't do this and I attach x, it's going to think that like my x belongs in the denominator, which I definitely don't want it to go. So that's me plugging that in. That's me ending the fraction, and that's me putting in x. Now I need to subtract 1.269, so minus 1.269. I'm going to close that parentheses, and I'm going to add 1.911. Let's hit graph and see what we get. All right, so we have a peak just outside. We only care about stuff between 0 and 10, so I'm going to fix my window. I'm going to change the y min to -1, okay, because I'm going from 0 to 10, but I always like to have that little bit of cushion. It goes to 11 for my x, okay. I need to add more stuff to the y, so I'm going to change the y max to 13. I don't know. That should do it, though, I think. Yeah, that should do it just fine. Now, I only care about stuff between here and 10, which is right here. So I need to find the lie. So let's see if A is true. The minimum value occurs at x equals 7.782. So I need to find the minimum value, which is going to be right there. So to find a minimum, we go to second calc. There's the word minimum, so we can hit 3 or scroll down and hit enter. In order to calculate the minimum, we've moved my cursor just to the left of the minimum, and then move it just to the right of the minimum for right bound. And then it's going to give me a spot where it says, my answer, my minimum, is going to be in between these two. Guess is always enter. I've never seen a time where it's never that. And my minimum occurs at x equals 7.782. So A is true. That's not the lie. A is not the one I want. So let's keep going. The maximum value occurs at y equals 11.562. So here's my maximum value. We're going to do the maximum the same way we did the min, but we're going to do 4, which is maximum. So let's go all the way to the left of that maximum value. There you are. For left bound, make sure you're to the left of it. Hit enter. For the right bound, make sure you're just to the right of it. Hit enter. And for guess, hit enter. And we care about the y value, not the x value. That's the trick behind this problem. The y value is 11.562. Sure is. So B is a true statement. So we need to keep going because the answer is not A and the answer is not B. The midline is the equation y equals 1.911. Now, I do not need to do anything on my calculator here because I find my midpoint by seeing what is added or subtracted to my entire function. So I have blah, 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 cosine, blah, 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 close parentheses. The number that's floating around right after that is my midline. So C is a true statement because my midline is 1.911. So D has to be a lie. Let's find out why. The graph is concave up at x equals 3.281. So let's go back to our graph. 3.281. Here's 1, here's 2, here's 3. So here's 3.8. And at that moment right there, that's concave down. It doesn't start going concave up until we hit the midline. Now, if you're paranoid and like, well, how do I know that that's not like 1.2 or something like that? Well, if you want to find out what the y value is, and if the y value is greater than the midline number, which is 1.911, you can hit second calc and type out your value at 3.281. 3.281. And since that number is much bigger than 1.911, that number occurs above the midline where it just so happens to be concave down. So after all of that, of course, it was problem or option D that was the lie, and we want the one that is the lie, so we are going to circle D. Oh boy, so much fun. The answer is D. Again, we wanted the lie. You were true. You were true. I didn't even need a calculator to see that you were true, but you were the one that was a lie because it happened like right around there. So that's concave down. So yeah, lots to do in that problem, but it's a tricky one, and we did it. Hope this helps. The function f is defined by f of x equals a sine b x plus c, close it plus d. This is the typical sinusoidal equation function where your amplitude, your frequency, your horizontal shift, your vertical shift for constants a, b, c, d. In the xy plane, the points 3, 4, and 5x represent a minimum value and a maximum value, respectively. On the graph of f, what are the values of a and d? Now, I'm not going to use a calculator here. There's a thing in your calculator called sine reg, and maybe this will do the job for you, but I'm not sure if you can only do sine reg with 2 points. I'm going to envision this without the use of a calculator. It tells me that you are a minimum and you are a maximum. So if I graph that, right, and it's all above here. If I graph that and my minimum is 1, 2, 3, and my maximum is at 5, and it happens at 4, and it happens at 8, it's going to look something like this. Okay? And there's not a ton, but we only need to find 2 things, A and D. Now, I said it a second ago, but I said it pretty quickly. I care about A, I care about D. Now, why I'm circling A and D and doing weird things with it, because I already started it and I don't feel like stopping. A stands for amplitude. Amplitude. Amplitude is half of the total height. Okay? Now, if I look at my total height here, I go from 4 to 8. So half, let me see, 8 minus 4 is 4. Half of 4 is 2. So my A is going to be 2. So that eliminates this guy. Now, what does D stand for? D stands for the midline. D stands for the midline. It's the area that cuts my line in half. But specifically, in the way you can get that numerically is whatever the low point is and whatever the high point is, it's literally half of that. So drawing this out, we can see that it's 6. If you were given terrible numbers and asked to find the same exact thing, you would do your minimum value plus your maximum value and divide that by 2. Midline is just like a midpoint where you add 2 things and divide by 2. So that gives you 12. 12 over 2 is 6. So your midline is 6. So D equals 6. So we need the one where A is 2, D is 6. It's going to be in sync. But again, one of those problems where you didn't really need a calculator. And again, sine reg, oh boy, sine reg, that's something we don't want to do. Sin regularly? Anyway, sine reg, I'm not even sure if that would work with 2 points. So I'm not even going to try it. I'm just going to stick with my own brain, the human calculator. Hope this helps. This is going to be terrible. Let P of x equals 3x to the 4k minus 111 all over e squared plus 3.3. K represents an integer. If P of 2 equals 61.465, find P of negative 1. So this is what I'm going to do. I'm going to run to a calculator, come back here, and then run back to a calculator again. What I need to do first is it just told us that if I were to plug in 2 for x, because, P of x, P of 2 means x is 2. If I were to plug in 2 for x, I'm going to get 61.465. Okay, so let's actually do this. Let's see what I can do without the use of a calculator first. I might regret this, but in doing this, it might make my life a lot easier. Okay, maybe. I don't know. Again, if I plug in at 2 for x, I get that number. So I'm going to rewrite this equation and say instead of p of x, 61.465 equals 3, and I'm going to put parentheses here because why not, 2 to the 4k minus 111 all over e squared plus 3.33. Now, my job is to get k all by itself. I'm going to multiply both sides by whatever e squared plus 3.33 is. That allows that to go away. So e squared plus 3.3, just 3. I think I said 3 before, but it's just that. All right, so now what I have is e squared plus 3.3 times 61.465 equals 3 parentheses 2 4k to the 4k minus 111. Let's add 111 to both sides. Add 111 to both sides. So now I have e squared plus 3.3 parentheses 61.465 parentheses plus 111 equals 3 parentheses 2 to the 4k parentheses. All right. Divide both sides by 3. Divide both sides by 3. And just to make life easier, that makes u, and u go away. I think we're all good with that. This is going to be the nightmare. I'm going to have to log base 2 both of these. Log base 2, log base 2. Now, if I log base 2, 2 to the 4k, what happens is that goes away and 4k drops down. So that goes away and 4k drops down. So let's get rid of that and just put 4k here. And if you're like, oh boy, are we done yet? No. Now I take this whole thing and divide it by 4 because I have to divide this by 4 to get k all by itself. So after all of that, I'm going to pray to the God that I serve that I type this whole thing into my calculator correctly. That'll give me k. And if you're like, hooray, then we're going to be done, right? No. We are not going to be done because once I have k, then what I have to do is plug that k into this equation and then plug in -1. Oh, we're only halfway done, boys and girls. So wish me luck. Let's plug this into our calculator and see what god-awful number we're probably going to get. Buckle up, baby. You're in for a wild ride. So we have a huge fraction, and the fraction is that huge log thing, as you can see on the right. That's the numerator, and then the denominator is 4. So I'm going to wrap the entire numerator in parentheses. Okay, now there's a little secret for log that if you hit math and scroll up a few times, there's log base. Okay, what that does is it allows you to plug in log base 2. See, before you would have to do the change of base formula, not anymore. Now what I have is a really big fraction, and with really big fractions, I like parentheses. So I have another parentheses. I'm going to type in e squared, so I could use, I guess, where's my e to the whatever? So second e to the whatever squared. Let's move over. Plus 3.3, close that parentheses, 61.465, close parentheses, plus 111. Ooh, that was a close one. And close that parentheses. So I have left 1, 2, 3 open. Now I'm back to 2 open. Now I'm at 3 open, 2 open, 1 open. So I need to put divided by 3 and close it. Now I take all of that and divide it by 4. And close that. And I get the number, you've got to be kidding me, 6. After all of that, I get 6? All right, I'll take it. Let's go back and use it. Now, remember, this gives us k. So k is 6. So let's go back and deal with that. Well, who'd have thunk it? After all of that, k is 6. So this is what I need to do. I need to do this again and replace k with 6, now that I know that k is 6, and then plug in -1 for x. So in my calculator, I'm going to plug in 3 times -1 to the 4 times 6, so to the 24, minus 111 all over e squared plus 3.3. So let's do that and see what happens. All right, so just like I said before, I'm paranoid about fractions, so let's put a parentheses there. 3 parentheses -1 to the 4 times 6, so I'm just going to put 24 because I don't want to risk screwing something up. Minus 111. Close that parentheses. Divide it by, open parentheses, e squared, so let's do this again, second ln squared, plus 3.3, close it, and we get -10.1037, so -10.104. So let's go back and select that one. All right, well, that was awful. That was awful, but after all of that, we got it, so... Yeah, I mean, this is one of those problems where the kids who get the 5s might get this one correct. It's really difficult. I mean, look at it. It's not fun, and it's awful, and it's the 35th problem that you're doing on a 40-problem multiple choice exam. So if you get to this point and you're like, well, this stinks, yeah, I don't blame you. But, we did it here, and maybe you'll see one like it. So I hope this helps. Two function models k and m are constructed to represent the population of deer in a forest. Both k of t and m of t represent the population of deer after t years for t is greater than or equal to 2. Interesting. I wonder if that's going to come into play later. If k of t is 200 minus 30 ln of t, and m of t is -5t plus 200, what is the first time t that the population predicted by the logarithmic? By the way, k is the logarithmic, and a model will be 10 years less. Ooh, look at me emphasizing that word with a bold font. 10 years less than the population predicted by the linear model, which would be m. You're the linear model. So I need to see when k is 10 less than m. So basically what I'm asking you is, when is k of t 10 less than m of t? Well, this is what I'm going to do. I'm going to run to my calculator, and I'm going to type this in the y sub 1 part. So I'm going to, in my calculator and in my TI-84 plus, I'm going to type in y sub 1 equals 200 minus 30 ln of t. All right, pretty simple. In my y sub 2, I care about when this is 10 less than that. So basically, if I have -5t plus 200, I want this to be 10 less than that. So I just subtract 10. So basically what I do is, in my graphing calculator, I don't want 200, I want 110, because I'm making an adjustment. So let's run to our calculators and see what happens when we take care of that. And by the way, what I'm going to do is I'm going to run to my calculator and find the intersection of these two lines. So let's do it. All right, let's do it. We have y equals, and we're going to type in just what I said we'd type in, 200 minus 30 ln of t. So here's my ln button. Of course, it's not going to be t, it's going to be x, but we know what to do. That's the first equation. The second equation is going to be -5 instead of tx plus 1,900. Now, since we are dealing with a 200 that's floating around in y sub 1 and a 190 that's floating around, those are y-intercepts. So I'm not going to hit graph and expect to see anything. So what I could do whenever I don't see anything, usually something that kind of works, is going to be zoom fit, which, I scroll up to 0 or I just hit 0 and hit enter and zoom fit. Now here's the thing. Let's just make believe that I'm blindly going to do this and not think at all. Okay. If I go to second calc and hit intersect, right, and I'm going to think, oh, okay, well, there's an intersection right there. Let's plug it in. Well, all right, let's do it. Let's plug it in. Let's go to the first curve, hit enter just to the left of it. Let's go to the right of it and hit enter just to the right of it and hit enter again. I get 1.922, and I'm like, oh, great, 1.922, that's awesome. Now, here's the issue. Do you remember in the original problem, t is supposed to be greater than or equal to 0. This isn't greater than or equal to 0. This isn't my answer. Now, if I notice my graphs, okay, this is the ln1, okay, and if you look back, since it's negative ln, that's why it's curling down like that. It's doing the mirror reflection over the x-axis. This is the linear guy. This is probably going to keep going down and to the right, and this is going to keep leveling out. And so these guys are going to intersect again off here, off screen. So what I need to do is maybe I just need to hit zoom out a little bit and see if I get another intersection. Oh, look at that. Another intersection, just like I predicted. So this original guy isn't going to do it. So we have to hit intersect again. So second trace intersect. Let's go over here, make sure I get close enough, but not too close, just to the left of it. Hit enter. Let's move just to the right of it. Hit enter. Always hit enter for guess. And it's giving me 13.7077. So 13.708 should be my guy. So I'm going to run back to my calculator, hit 13.708, and get my answer. Tricky, 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 tricky problem. This was a tricky problem. First things first, it couldn't be simple where they were just like, hey, find out when these guys are equal to each other. They had to throw this part in there. Then they also had to throw this part in there. So it's a tricky problem. So be prepared for tricky problems like that guy right there. Hope this helps. How many complete cycles will y equals 4 sine 4x minus 3 sine 6x complete on the interval 0 is less than or equal to x is less than or equal to 100? So, all right, well, this is what I would do. The last thing I want to do is graph that. And I know whenever I have like weird things like this, it's not going to be like, ooh, all pretty and stuff. It's going to be like this, where it kind of goes back and forth, almost like a heart rate thing. Of course, it's never going to look like that. I just don't know how to draw. So what I'm going to do is I'm going to graph this in my calculator, right? And find out how long it takes for one period to occur. Okay, so if it goes up and down and then slows down and then repeats the process right around here, I'm going to find out what one period is. Once I have one period, say it's 10, it's probably not, but say it's 10, then what I'll do is I'll just divide 100 by 10 and get how many times it repeats. Watch it be 10. I actually don't know, but let's see what happens, and maybe it is 10, and maybe I've just wasted a whole bunch of your time. Not my time, YouTube money. Let's go to our calculator. Y equals 4, there's my sine, 4x, close parentheses, minus 3 sine 6x. Now this is what I'm going to do. I'm going to hit window before I graph this. Actually, I'm sorry, zoom before I graph this, and zoom trig. Usually that gives me friendly pi-ish numbers. Maybe it will here, maybe it won't here. I don't know. Let's see what happens. Okay, I hated that. I hated that a lot. So why don't I not do that? And why don't I change like a window from like 0 to, let's do 2 pi. just to see what happens. Maybe that window is not good enough. A lot of what we're doing is kind of like seeing a window that works for us. That is much better. Okay, that is much better. It looks like what's happening is we start kind of like at this weird thing, like at this almost negative coast looking thing, and then way up, then down, then way up, then kind of down, then it repeats at that guy right there. Now let's use common sense. Since the window I created was 0 to 2 pi, it seems to repeat right here in the middle of 0 and 2 pi. This is going to come as a shock, but that number in between 0 and 2 pi is pi. Now, if you're ever uncertain as to where things are, you can always do an intersect, or you can always do second calc and do a 0. But I'm fairly confident that that number right there is pi, since that number right there is 2 pi. So I'm going to go back and finish the problem, and I'll probably have to come back here again because the numbers are going to be gross. But now that I know that my period is pi, that makes the problem a whole lot easier. Okay, so as you can see, the period was pi. Okay, not pleasant, not fun, but the period was pi. Now, the last thing that I said before that I wanted to do is try to count how many cycles happened during that. So what I'm going to do instead is I'm going to run to my calculator and find out what 100 divided by pi is. Now, before I do that and circle my answer, it wants to know how many complete cycles will occur from the beginning to the end, from 0 to 100. Now, I'm definitely going to get a decimal here. No matter what decimal I get, I'm going to round down because I have to complete a cycle. So let's just make believe that I get some number like 9.99. Did I complete a 10th cycle? No. So the answer is just going to be 9. So that's not what's going on, but let's just make believe that is what's going on so I can go back to my calculator and see what happens. All right, so 100 divided by, that is not the button I wanted to hit. Start over, start over, start over. All right, so 100 divided by pi, which is second caret thing, is going to give me 31.83. Who cares? As I said previously, we're rounding this guy down. So let's round it down to 31, go back and circle the answer, and I'm done. Okay, so we got 31 point who cares, which means no matter what, we round down to 31 because we're completing cycles. If I were smart, I would have made 32 an option. But I guess I'm just not smart. I don't know what I'm doing. Either way, weird problem. Hope this helps. The graph shows a piecewise function j of x. If h of x represents the inverse of j of x, what is the maximum value of h of x? Oh, cool, a calculator problem that we don't need a calculator for. It's happened a few times if you're watching all of my videos, and this is where it happens again. I don't need a calculator for this. Why it's in the calculator section, I don't know, to confuse you. But what I have is I have a regular function here, and I care about the inverse. Now, I am not an artist. What I don't want to do is I don't want to graph this just by looking at it. So let's use the idea of what an inverse actually does. First off, this is j of x. Okay, so let's write out a table for j of x using what looks like the 4 dots that I have. So I have x, I have j of x, and I have 0, 0. That's an obvious point. I have 4, 4. That's an obvious point. I have 5, 3. That's an obvious point. And I have 8, 9. That's an obvious point. Now, the first step in finding an inverse is swap the y and the x values. So why should that change here? So 0, 0 swapped becomes 0, 0. Good job. 4, 4 swapped becomes 4, 4. Good job. 5, 3 swapped, finally a change, is 3, 5. Good job. And then 8, 9 swapped is 9, 8. Now this is my h of x function. Now if you wanted to graph it, you could dot here, 3, 5 is a dot here, and then 9, 8 is a dot here. So you would connect these two. Now, by the way, if you're like, why hasn't it changed here? Graphically, the inverse is a reflection over the y equals x axis. This part right here is the graph y equals x. So this is a reflection, so nothing changes. Now we finally do have a reflection. And oh, please let me graph this well. Nailed it. Now that was extracurricular. I didn't need to do any of that. What I really needed to do is, now that I have h of x, I just needed to find out the maximum value, and that maximum value is 8, not 9. 9 is not a maximum value. When they talk about maximum values, they mean the maximum value that shows up on the y-axis. Okay, so in this case, it's going to be 8C is my guy. So we did a little extra here, but you know what? I had fun. And look at the pretty little drawing we made. It looks like a arrow with a disability. 39th problem, or 38th problem. Oh gosh, hope this helps. Let d of x equals 4 point sine, parentheses, 2.51x minus 2, close it, and b of x equal d of x, which is that, plus 2.5. Which of the following is not a 0 of b of x on 0 pi? All right, well, b of x is just d of x added to 2.5, so let's change that. We care about b of x. It would be nice if I had the pen. B of x is now going to be 4.5 sine 2.51x minus 2, in parentheses, plus 2.5. Okay, so all I did was rewrite d of x, add the 2.5. I just added the midline there. So what I need is, I need to zero in on 0 to pi, and I need to graph this on a graphing calculator and find out which one of these is not a 0, which means 3 of these will be. So let's go to our calculator and see what happens. All right, so we've got 4.5, we've got sine, we've got parentheses, 2.51x minus 2, so 2.51x minus 2, close it, but now I'm adding 2.5. So I care about when things happen between 0 and pi, so why don't I just run to my window and make the x min 0 and the x max pi. Okay, since I'm lifting this up 2.5 and my amplitude is 4.5, this will go up to 6, so we'll put you at 7. This is not necessary, by the way. This is me just adding stuff. And let's go down to -5. That way we get a little bit clearer or zoom in version of what we're dealing with. See what I did? It wasn't necessary to change the y min, but changing the x min and max made life better. So 0 number uno, 0 numero 2, and 0 option D is right there. I made a joke. Came from like Home Alone or something like that. I need to find all 3 of these zeros. Now, you might be able to look at these and say, I know my answer already, it's B. Great. But let's just make sure we know what we're doing. If I want to find exactly what the values are for 0, you hit second, calc, and go to 0. All right. Zeros are where your line or curve crosses the x-axis. So to find the first 0, I go to the left of it for the left bound, hit enter. Go to the right of it for the right bound, hit enter. This guy tells me that my 0 exists in between the 2 little arrows, which is correct. Always hit enter for guess, and we get 0.562, which means A is a 0, which means A, we're going to cross it out. Now to find the second one over here, which is going to be 2 point something, we hit second calc, we hit 0 again, we go all the way over here just to the left of where it crosses the x-axis, hit enter. Let's go to the right of where it crosses the x-axis, hit enter. For guess, hit enter. And now C is no longer an option that I want because 2.283 is a 0 and I want the one that is not a 0. So let's find this 3 point whatever it is. Second calc 0. Let's go just to the left of it, just to the right of it, in the little space that I have, hit enter, 3.065. So it looks like the guy that wasn't my guy was 2. Again, could I have noticed that immediately without having to do the 3-0 things that I just did? Yep, but I wanted to show you that just in case you run into a problem where you need to find zeros and you're just going to have to do the process anyway. So let's go back and circle C. No, circle B. Oh, wait, no, circle B. Ugh. Let's go back and circle our answer. If only I knew how to speak. The answer is B. And again, we could have noticed that without having to do the zeros thing, but it was good for you. It was good for me, that's for sure. Speaking, though, I'm just not good at. It's too late in the evening for me. And too late in the test, because this is problem 39, which means we have one more multiple choice to go. So hope this helps. A water wheel spins clockwise at a rate of 90 complete revolutions per 60 minutes. The radius of the water wheel is 12 feet. The center is built 8 feet above water level. One of the spokes of the water wheel is painted green. Which of the following sinusoidal functions models the height of the edge of the green spoke h with respect to time in minutes denoted as m? So this is a calculator problem. I ain't going to use it. Sine reg here, which is, sinusoidal regression, just like linear regression, just like quadratic and exponential, all that stuff, ln reg, I guess you could use it. But it's sine reg you're going to want to use when you're given a bunch of points. I'm not given any points here, so I'm not going to use sine reg. So I'm going to use my human calculator, my brain. Now, I like to create a picture whenever I deal with these and use that picture as my guide. What do I have? Well, the green spoke is right here at the middle. Okay, so I have a midline, and my midline is 8 feet above water level. So my midline is going to be at 8. So let's put an 8 right there. There is my midline. Hooray. Now, whenever you're given a sinusoidal problem and you are given a radius, that radius is your amplitude. So what's going to happen is as this guy turns counterclockwise, you're going to hit a tippy top. And that tippy top is going to be the length of the radius. So 12 plus that radius is going to be 20 feet up in the air. So that's going to be my maximum, is 20. As this guy goes underwater, it's going to go under 12 taken away from 6, which means it's going to bottom out at -4. And if you're thinking, whoa, buddy, you can't have negatives for real-life sinusoidal problems. You sure can if you're going underwater, and this looks like it's underwater to me. So I'm going to go with that. Now, as this rotates counterclockwise, you are starting at the midline and moving up and then down, and then up and then down. So you're starting at the midline and you're moving up and then down, and then up, and then I'm out of space. Okay. Now, that, to me, looks like a sine. A sine, I know here it starts at 8, but a sine starts at usually the x-axis, or in this case, the midline. It starts right there at that origin point and goes up and down and up and down and blah, blah, blah. So this is sine. So, I guess we have no choice, but it is sine. Now, what this means is as I start to build this equation, I know one thing I don't have. Now, what I do have is I have an amplitude, I have a midline. What I need to do is figure out what my period is. Now, if I'm looking at all this and trying to write an equation, I'm comparing it to y equals a parentheses sine parentheses b parentheses x minus c, close it. Actually, I really don't like that parentheses there. Let's get rid of you. Close it, and then plus d at the end. Okay? Now, what's what? Well, you're my amplitude. I already know that. So my amplitude is 12. You're my midline. I already know that. What I also know is since this is starting at sine, I'm not going to have a horizontal transformation or translation. I'm not going to move left or right anywhere. Okay, so that minus c is useless. What I don't have is b. B is the frequency. B is not the period. I'm going to have a hard time trying to figure out using these numbers what the frequency are. So what I'll do instead is I will find out what the period is. Now the period lives right here where it starts over. If this guy is going to do 90 things in a course of 60 minutes, that means this number right here is going to be 60 over 90, which is 2/3. Now, does that mean I'm going to do 2/3 here? No, that's not even an option. That's my frequency. The way, actually I do, well, I don't, it's 90/60. Oh, that was a close one. What I need to do is I need to find out what my frequency is. Now, my frequency is found out by doing 2 pi over the period, which is 2/3. Okay, multiply the top and the bottom by 3/2 rather, it's reciprocal. So that crosses out, that crosses out, that crosses out, that crosses out. I now have 2 pi times 3/2, so the 2's cross out, and I'm left with 3 pi. So my period is 3 pi. So putting this all together and using h of m and using m instead of x, I have h of m equals 12 sine 3 pi x, because I don't have a horizontal translation, or m, plus 8. So that's problem number 40 in our multiple choice test. Okay, could I use a calculator? Probably, but I just, I didn't want to because I didn't need to. And sinusoidal regression is just not fun if you don't have any points. This, however, is fun. So 40 problems down. This is a typical practice test, what it would look like. Hope this helps.